Today, we're taking on something big, building a 1kW-3kW induction heater, powered by an earth battery and supercapacitor bank. This means we're creating high-power heating, completely off-grid, using nothing but the energy stored in the earth. Let's get started. Before we start building, let's break down how this system works. First, we'll collect electricity from the earth battery. This gives us a steady low-voltage power source. But we need much higher voltage for induction heating. So we'll use a supercapacitor bank to store energy and a DC-DC boost converter to increase the voltage to at least 48V to 100V. Then we send this boosted power into an induction heater circuit, which uses a power MOSFET, or IGBT switch, and a high-frequency coil to generate powerful heat. And because high power generates heat in our electronics too, we'll build a water-cooled system to keep things running efficiently. Alright, now that we understand how it works, let's get our materials together. Once we have everything ready, it's time to assemble the earth battery system. The first step is to build our power source, the earth battery. We'll be using copper and zinc plates buried in moist soil spaced about 2 feet apart. This creates an electrochemical reaction that generates low-voltage electricity. Now, we connect these in series to increase the voltage, and in parallel to increase the current. We'll then send this power into a supercapacitor bank to stabilize it before boosting it up. Now that our earth battery is set up, let's boost the voltage and get it ready for the induction heater. Our earth battery gives us low voltage, but we need at least 48V 100V for the induction heater. That's where the DC-DC boost converter comes in. We connect the output of our supercapacitor bank to the input of the boost converter, then fine-tune the voltage output. Perfect. Now that we have a high enough voltage, let's wire up the induction heater circuit. This is the heart of our system, the induction heating circuit. Here's what's happening. Current limiting resistor protects against power surges. Schottky diode prevents voltage from backfeeding. Power MOSFET. IGBT acts as a high-speed switch, turning power on and off rapidly. Induction coil generates a strong electromagnetic field that heats metal. PWM controller controls the power and frequency for optimal heating. Now, we're going to connect the boosted voltage to the induction circuit and then test our heating setup. Induction heating generates a lot of heat, not just in the metal, but in the electronics themselves. So we're installing a water cooling system to keep it from overheating. Our pump will push cold water through the copper coil, absorbing excess heat and cooling it down before recirculating. With the cooling system in place, it's finally time to fire up the induction heater. All right, moment of truth. We place the steel rod inside the coil, turn on the power, and boom! The metal starts heating up almost instantly. This works because the coil generates a high-frequency magnetic field, which excites the metal atoms and causes them to heat up. Now, let's see how different metals respond and compare heating times. This system is powerful, efficient, and most importantly, off-grid, thanks to our earth battery and supercapacitor setup. This project proves that we can generate high-power heating from the Earth's natural energy. By combining earth batteries, supercapacitors, and efficient induction circuits, we can create self-sustaining systems that don't rely on the grid. If you enjoyed this build and want to see more, hit like and subscribe to support our channel, and drop a comment below with what you'd like us to build next. Until next time, keep innovating.